Hello, statistics student. This video is for chapter 4.3, Binomial Probability Distribution. Binomial distribution is used to find probability of a particular discrete random variable, x, where x is a discrete value because it's all about discrete random variable, and it happens by chance, but it satisfies 4 requirements. So the first requirement is this x, this value that is occur by chance, is the result of a fixed number of trials. So you must be repeating the whole procedures can be broken down into n trials, and it has the fixed number. So you will be repeating doing something and you count something. So x is a count. And the trial must be independent. So you are counting something and you are counting something that you call a success. So you could be counting something that is like a business fail or someone does not pass the test, but whatever that you're counting is technically called a success. And the probability of success for every single trial is fixed. Is the same in all trials. That's the fourth one. And then 3 is you have 2 outcomes, success and failure. The one that you're counting is called success. The one that you're not counting is failure, where x is the number of success in trials. So if your probability x number is can satisfy all these 4 requirements, then we call x can be modeled by binomial distribution. So the reason why binomial distribution is very good is it can be used to model so many things that happen by chance in real life. So long as you are counting something and your count stop at a certain trials, and they're all independent. Some numbers that we need to pay attention to is n. N is the number of trials that you are counting, and you're counting number of times that certain things happen in the n trials. And also the success in one trial is p, probability of success. So we simplify as p. The probability of failure in one trial is 1 minus p, of course, because it's a complementary, and it's called q usually. So p of x means there's x number of success in n trials. So a lot of times when we do sampling is actually can be modeled by binomial, but the independence selection could be difficult if we are sampling without replacement, because the population size all of a sudden becomes smaller and smaller. But so for sampling, if our sample size is less than 5% of the population, we can use the 5% guideline to assume independence. Okay. So this binomial distribution can be used to calculate probability of a lot of stuff. And in particular, it can be used to calculate sampling. So what is the number of a particular things that happen in a sample? So for example, we can determine if any of these are binomial or not. If X is the number of adults out of 5 who use iPhone, so you pick 5 adults, right? 5 adults. Out of the 5 adults, you count how many that use iPhone. So it could be 0, it could be 1, up to 5, right? So they all occur by chance, and we want to find out what is the chance that X is equal to 1 out of 5, only 1 adult use, or out of 5, all 5 adults use iPhone. So that is X. Okay. So can this be uh, um, followed or can model by binomial distribution? We say it's yes. And we say it can be modeled by binomial distribution with the parameter n is equal to 5 and p is the probability of total number of adults that use iPhone. So if in the whole population, we know the percentage that use iPhone, so we can have p equal to 0.8, or I don't know what is the market share of iPhone right now, then we can actually find the probability that some out of 5, how many would use iPhone. Okay, so we can calculate it by formula and also by PDF. B is number of times a student raised his or her hand in class. So we select a student in a class, and we are looking at the number of times a student raised his or her hand. Now, is there a number of trials that we have? We don't know how many times the teacher invite a student to raise hand, right? Or the student can raise hands to ask a question. So there is no fixed number of trials. So this cannot be modeled by binomial distribution. But it is a random variable because if you randomly pick a student, there is a chance that the student raised his or her hand 0 time, 1 time, 2 times, etc. So it is a discrete random variable, but it cannot be modeled by binomial because there's no fixed number of trials. C, x is the number of 1 after tossing a die 7 times. So you toss a die 7 times, but you watch out for 1. So 1 is your success, right? 1 is the success, not 1 is the failure. So that works for two outcome. There is a fixed number of trial because you toss a die 7 times, so n is 7. The trials are independent, but because every time you toss, it has nothing to do with whatever that has happened, right? And then there's two outcome, either 1 or not 1. And the fourth is the probability of getting a 1 is the same in all of time, right? So C can be binomial, and the number of trials is 7 because you toss 7 times, and the probability of getting a 1 every time is 1/6. So these two things can be used to find the probability of x. D, x is the number of toss until 1 shows up. So you keep on tossing the dice and you count whether it's showing 1 is showing up or not. So you're counting something, but you're counting the number of times until 1 shows up. So there's no fixed number of trials. So um, D is not can be modeled by binomial. E is the way the student commute to school. The way to student commute to school has nothing to do with a number, right? It is just, oh, is it by car or by carpool or by Uber or by bus, right? So these are not binomial. So it is not like counts of success. So it cannot be modeled by binomial distribution. Why do we so concerned about whether x, when it is a discrete random variable, can be modeled by binomial? Because the probability of x can be defined by formula. You don't need a table to look up a probability. And you can also use a um, online calculator to find it. Graphing calculator can be used to find binomial. And here I list two calculators, StatDis and also the online statbook binomial calculator. I actually like this a little bit better, the online statbook, because it also has a graph, but the problem is p is limited to 2 decimal places. So in general, if p is more than 2 decimal places, you cannot. So by default, in all my calculation and in class, I will teach you how to use StatDis. Okay, StatDis is our like default calculator, so it's okay. It is a little more tricky than the online statbook, but it's you can get it to work. Now, how do we have this formula? This formula looks very complicated. So the way you calculate this formula is if I want so this is probability of X successes in N trials. When we say X means X success in N trials. You are watching for a particular things to happen called success, and out of N time you count how many times that success shows up. So if probability of one success in one trial is P, then if I want X success, then I could just do P times P times P, P times, right? X times. So that's why we have P of X. And then the rest will be not successful, right? Q times Q. Q is 1 minus P, is failure. So it will be N minus 1 time. And then you're assuming that they occur in a certain way, right? So this is one way of having X success and N minus X time. And you multiply them because you want actually X successes. But all these can be arranged in different order. And the way to arrange PPP, QQQ in different order is n factorial over x factorial n minus x factorial. Factorial means n factorial means starting from 1, some 2, times 3, all the ways times n. Or you can say from n minus 1, all the ways to 1. So it has to do with how many ways can you arrange p repeated x repeated p and n minus x repeated q. So this would tells you how many times this can happen, and you multiply them. That would find you the probability by formula. And of course, we don't have to use it. We can use an online calculator to do it. So let's do some example on how we can use it to. You can use the online calculator. If I am doing 12 trials, I'm watching something to be success. Every time the things to be successful is 0.24, and I want to know out of 12 times I have exactly 5 success. So we will use the statistics calculator. I'm going to show you here. Statistics. So you would enter statistics, and the way to get the calculator is analysis, probability distribution, binomial distribution. It's quite indirect. Okay, again, you are trying to do some analysis. You are not using data. So you will say analysis, probability distribution. You are doing probability. And this is binomial. So you will have this screen. Now, if you have any data in the table, they will replace you. So there's a warning here. And the two things that you need to enter is the number of success. For example, in our notes, we want to do 12 and 0.24. 12 times, and each time there's 24 chance of success. And then you want to figure out what is the chance of 5 out of the 12. There's only 5 success, because every time you can have the first one success, second one success, the first 5 success, whatever, but totally there's only 5, okay, out of 12. So if you want to use the calculator, the formula you can calculate, but you can also use the calculator. They would do the formula behind the scenes for you. So you just hit evaluate. So they would have like a list of numbers that shows up. Okay. So the one that we want is P of X because we want exactly 5 success. They also give you 2 column. One is X or fewer. That means 5 or 4 or 3 or 2 or 1, because we know sometimes we want to find out what is 5 or more, 5 or fewer. We can sometimes want 5 or greater. Okay, so because x is 5, so you replace it here to say this just means 5 or greater. I have 5 or greater success, so that's 0.137. And usually we do 4 places or 3 places. Okay, so P of X means 5. X is 5, so 5 success, exactly 5 success out of 12, which is really low. 5 or fewer would be very high because there's only 24% of having 1 success, right? You see, most of the time it's not successful. So it's 5 or fewer is really high. 5 or greater is quite low, 0.137. Okay, X is 5, then is that. Now, if you enter 0, and press enter, and press devour, they actually give you the whole table. This maybe you like it, because after that then you don't have to look at it anymore, but I usually just do one. So if I want that one, I choose that one, so I can just look at one number. Okay, so that in that case I'll write down the answer. Exactly 5 is P of X 0.0524, right? So that would be 0.0524. What about 5 or more? So it's already here, right? 5 or more would be 0.1377. 0.1377. So, and then 5 or fewer, we use the other one, which is 0.9547. 0.9547. What about more than 5? Can I read it from here? No, because more than 5 would mean 6 or more, right? So I have to adjust it to 6 and then evaluate. So 6 or more would be 0.0453. Less than 5, for less than 5, I have to